Good morning, all of you. Welcome to Sri Jayendra Rank Zone. Now we are discussing group 15 elements. So far, we have completed already nitrogen and its compounds also. Now we are going to start new topic in this chapter, the last topic, that is study of phosphorus. So now we are going to learn about phosphorus and its compounds. Phosphorus and its compounds. So then this topic will be completed. That is only group 15 will be completed, and next we will start group 16. I hope it is clear. Let us start now. So, phosphorus. So, it is another element in the group 15th, that is phosphorus. Phosphorus exists in the following allotropic forms: white phosphorus, red phosphorus, and black phosphorus. So, white phosphorus. White phosphorus is a translucent white waxy solid. Phosphorus exists in three forms, that is white phosphorus, black phosphorus, and red phosphorus. So white phosphorus is a translucent white waxy solid. It is insoluble in water but soluble in carbon disulfide. It is insoluble in water and it is soluble in carbon disulfide. This point is important. So white phosphorus is insoluble in water and it is soluble in carbon disulfide. It is poisonous in nature. It glows in dark. That's why it is called chemiluminescence. Means it glows in dark. That is called white phosphorus. I hope it is clear. So these are the allotropic forms of phosphorus. White phosphorus. Next, white phosphorus preparation. It undergoes disproportionation when treated with alkali. This reaction already we have seen. White phosphorus when combined with an alkali, that is sodium hydroxide or potassium hydroxide. Alkali means soluble base. So when it combines with sodium hydroxide or potassium hydroxide, it forms phosphine, a poisonous gas, and also sodium hypophosphate. So here phosphorus is undergoing disproportionation because here the oxygen state of phosphorus is 0 and here it is -3 and here it should be, so 1 plus 2 minus 2 plus x minus 4 is equal to 0 because oxygen is -2. So 1 is sodium, 2 because 2 hydrogens are there. So oxygen state of hydrogen is +2. So 1 plus 2 plus x minus 4 is equal to 0. So m plus 3 minus 4. So x is equal to -1. X is equal to 1, sorry. So that's 1. So phosphorus is changing from -3 to 0 to -3. This decrease in oxidation number, and 0 to +1. It is increase in oxidation number. So the same element is undergoing. This is -3. Same element is undergoing oxidation as well as reduction. So that's why it is called as disproportionation reaction. What is disproportionation reaction? If the one of the element in the chemical reaction undergoes oxidation as well as reduction, undergoing redox reaction, it is called as disproportionation reaction. So here phosphorus undergoes disproportionation reaction when treated with alkali, that is white phosphorus. So this is white phosphorus. White phosphorus catches fire immediately in air. It forms P4O10, that is diphosphorus pentoxide, P4O10. Dense white fumes will be formed. So white phosphorus catches fire immediately in air. So it is highly reactive. I hope it is clear. Next, structure of white phosphorus. It has P4. The atomicity of phosphorus is 4. What is atomicity? Atomicity means number of atoms present in its molecule. Atomicity of phosphorus is 4. Any phosphorus, either white phosphorus, black phosphorus, or red phosphorus. Atomicity of phosphorus is 4 because 4 atoms are present in its molecule. That's why it is P4 molecule. P4 molecule. P4 has tetrahedral shape and the number of pp bonds in P4 is 6. How many pp bonds? 1, 2, 3, 4, 5, and 6. So total it is 6. This is 1. Outside it is 4. 1, 2, 3, 4. And inside it is 1. Again it is 1. So it has number of pp bonds is 6. pp bonds in P4 molecule is 6. And the bond angle of PPP angle is 60 degrees. The expected tetrahedral angle is 109.5 degrees. Due to this angular strain, P4 is highly unstable and reactive. So it is highly unstable and reactive. That's why it catches fire in air. I hope it is clear. Next, red phosphorus. Red phosphorus possesses iron gray luster. It is just like gray color luster. Luster means shiny. It is odorless, non-poisonous, and insoluble in water and carbon disulfide again. So if you go for test for phosphorus, whether it is white phosphorus or red phosphorus, we can distinguish easily. Both the phosphorus are insoluble in water, but white phosphorus is soluble in carbon disulfide, whereas red phosphorus is not soluble even in carbon disulfide. It is less reactive than white phosphorus. So out of all the allotropes of phosphorus, red phosphorus is less reactive than white phosphorus, and white phosphorus is most reactive. It is polymer of P4 containing chains of P4 tetrahedral units linked together. So many P4 tetrahedral units join together to form red phosphorus. I hope it is clear. So this is like this. Not only single molecule, it has tetrahedral units joined together. So it is a big polymer. Polymer means joining of. It's a big molecule. Polymer means so many molecules combine together to form a polymer. So that's why it is called polymer. Polymer means so many molecules will combine together. Example here, three P4 molecules are joined together and so on. So that's why it is called polymer. So red phosphorus is a polymer. Red phosphorus is a polymer of P4 containing chains of P4 tetrahedral units linked together. I hope it is clear. So this is called red phosphorus. It is less reactive than white phosphorus and it is insoluble in water as well as in carbon disulfide. One simple example of red phosphorus I'll tell you. Red phosphorus means on the matchbox we have phosphorus is coating on the matchbox. Phosphorus is coated, and with the matchstick will be lightened to phosphorus so that it gets fire. So that is nothing but red phosphorus only. That is nothing but what? Red phosphorus. Next, black phosphorus. Black phosphorus has two forms, alpha black and beta black phosphorus. Alpha black phosphorus is formed when red phosphorus is heated. This is very, very important. These sentences they'll ask in the competitive exam. Alpha black phosphorus is formed when red phosphorus is heated in a sealed tube at 803 kelvins, whereas beta black phosphorus is prepared by heating white phosphorus at 473 kelvins at high pressure. So black phosphorus contains again two types. One is alpha black phosphorus and another is beta black phosphorus. And alpha black phosphorus is prepared from red phosphorus, whereas beta black phosphorus is prepared by heating white phosphorus at 473 kelvins at high pressure. So this is the preparation of black phosphorus. So we have three allotropes of phosphorus: white phosphorus, red phosphorus, and black phosphorus. And black phosphorus further divided into two categories: black phosphorus and beta black phosphorus. Let us see more details about this now. Now, phosphine. So the first component in phosphorus is phosphine. Phosphine is a hydride of phosphorus. It is also called as hydride of phosphorus because phosphorus when combined with hydrogen. So hydride of phosphorus means phosphorus with hydrogen. That's why it is called hydride of phosphorus. And it is prepared by the reaction of calcium phosphide, Ca3P2 with water or dilute HCl. So calcium phosphide on reaction with water, it forms phosphine gas, which is highly poisonous, and calcium phosphate on reaction with dilute HCl also forms calcium hydroxide and calcium phosphine in the first case and calcium chloride and phosphine in the second case. So this is the preparation of phosphine. It is also prepared by heating white phosphorus with white alkali. With alkali, this reaction we have seen the disproportionation reaction of phosphorus. That is when white phosphorus is treated with alkali, it forms phosphine gas along with sodium hypophosphorate. So this is nothing but preparation of phosphine. We have three preparations. One is from calcium phosphate and that is from white phosphorus. From white phosphorus we can obtain phosphine gas. So this phosphine is highly poisonous. So it is a colorless gas with a rotten fish smell and is highly poisonous. As I told you, phosphine gas is more volatile and it is highly poisonous. It explodes when comes in contact with traces of oxidizing agents like nitric acid, chlorine gas, and bromine. So it explodes. This phosphine will explode when it comes in contact with traces of oxidizing agents such as nitric acid, chlorine, and bromine. So if you take this phosphine gas along with nitric acid or chlorine gas or bromine gas, it gets exploded. So it is slightly soluble in water. The solution of phosphine in water decomposes in the presence of light, giving red phosphorus and hydrogen. See, very important point. The solution of phosphine in water decomposes in the presence of light, giving red phosphorus and hydrogen. Red, red phosphorus is less reactive. When phosphine is absorbed in copper sulfate or when phosphine is absorbed in copper sulfate or mercury chloride solution, corresponding phosphates are formed. So example, copper sulfate on reaction with phosphine gas, it forms copper phosphide plus sulfuric acid. And with mercury chloride, it forms mercury phosphide along with HCl. So this reaction is very important. They can ask in the objective question, what happens when phosphine is treated with copper sulfate along with or mercury chloride. So HgCl2 is mercury chloride. So mercury chloride along and copper sulfate they form their corresponding phosphates, that is copper phosphide and mercuric phosphide along with HCl and H2SO4. Phosphine acts as Lewis base, very, very important, because since phosphine in the phosphine molecule has one lone pair of electrons, so it is ready to donate this lone pair of electrons. That's why it is acting as Lewis base. What is Lewis base? The substance which donates electrons, donates its lone pair of electron is said to be Lewis base, and the substance which accepts the lone pair of electron is called Lewis acid. So ammonia is a base, and phosphine is also a base. So phosphine acts as Lewis base. It reacts with acidic species to form phosphonium salts. So when phosphine combines with HBr, it forms PH4Br, phosphonium bromide. It is called PH4Br with HBr. So it reacts with acidic species to form phosphonium salts, and it donates its lone pair of electrons to HBr. So that's why it is a Lewis base. Next. So what is Lewis base? To understand, Lewis base is nothing but the substance which can donate its lone pair of electrons. Lone pair of electrons is called Lewis base, and phosphine has one lone pair of electron, hence it is acting as a Lewis base. And when it's treated with acid, it forms phosphonium salt. It forms phosphonium salt. Next, very, very important. This is Holmes signal. What is Holmes signal? This is used in railway tracks. The containers containing calcium carbide and calcium phosphate are pierced and thrown into sea. Are pierced and thrown into sea means these two combination they are combined together and thrown into sea. It forms P4O6 which catches fire. The calcium carbide reacts with water to form acetylene gas, which serves as fuel. These gases will burn and serves as a signal. When they burn and gives a signal, so Ca3P2 H2O gives us pH3 gas, that is phosphine gas. That is calcium phosphate on reaction with water. This already we know in the preparation of phosphine. This phosphine gas changes to P2H4 and further changes to P4O6 so that it catches fire and it gives a fuel. And this the calcium carbide so formed combines with water to form acetylene gas. It is fuel. So that's why it is called Holmes signal. Holmes signal, they are used to know the routes in the sea. So these containers containing calcium carbide and calcium phosphate are pierced and thrown into sea. If the sea for the route map in the sea, they can use this signal for the route in the sea. They can identify the route in the sea so that easily they can see the obstacles present in the sea. If there any mountains are there, then they can see that mountain by the fire of this Holmes signal. So that's why these gases liberated will be burned. So calcium carbide and calcium phosphide. Phosphide will give you P4O6 which catches fire, and calcium carbide will give you acetylene gas which is used as fuel. So that fire will be added with this fuel, so that what happens, it gives a bright signal. So that signal is used to know the route in the sea. I hope it is clear. So this is called Holmes signal. So what is Holmes signal consisting of? It contains a container containing calcium carbide. This they'll ask in the objective. Holmes signal contains a container containing calcium carbide and calcium phosphate. From calcium phosphide along with water, we'll get phosphine gas, which further changes to P4O6, which catches fire. And from calcium carbide with water, it forms acetylene gas, which is used as fuel. So both these compounds are being formed, which results in a big fire. So that is serves as a signal. That big fire serves as a signal. So this is called Holmes signal. Definitely they'll ask in the examination what is Holmes signal consisting of. So you have to remember this point. Very, very important this slide. So please note down in your classwork. This slide is most important. Next, halides of phosphorus. PCl3. What are the different types of halide phosphorus can form? It can form two types of halides. One is px3, and there is px5. It can, due to the availability of d orbital, empty d orbital, it can form px5 as well as px3. Two types of halides it can form. So what are those two types of halides? Now we are going to see now. So first halide, that is PCl3, that is px3. So phosphorus trichloride is prepared by the direct combination of chlorine with hot white phosphorus. From white phosphorus on direct combination with chlorine, it forms phosphorus trichloride. It is also obtained by the action of thionyl chloride. SOCl2 is called thionyl chloride. Thionyl chloride is called what? SOCl2 with white phosphorus. So almost in all the reactions, what are the reactions we write using phosphorus? That is based on white phosphorus only, because white phosphorus is not reactive. So definitely we'll take only white phosphorus. So that's why which of the out of the following allotropes which is most reactive means white phosphorus. White phosphorus is most reactive. So it is also obtained by the action of thionyl chloride with white phosphorus. So thionyl chloride on reaction with white phosphorus, it forms PCl3, that is phosphorus trichloride along with sulfur dioxide along with thionyl chloride. Sulfonyl chloride. This is called sulfonyl chloride. What is this called? Sulfonyl chloride. Sulfonyl chloride. This is called S2Cl2. And thionyl chloride is nothing but SOCl2. SOCl2 is called thionyl chloride. I hope it is clear. So how phosphorus chloride trichloride is obtained by two methods. When white phosphorus is treated with direct chlorine gas, direct combination of chlorine with hot white phosphorus, it forms PCl3, and also it is obtained by the reaction of phosphorus with thionyl chloride. It forms sulfur dioxide gas and sulfonyl chloride. I hope it is clear. So phosphorus will form two types of allotropes. Sorry, two types of halides. One is PCl3 and another, sorry, PX3 and another is PX5. Let us see now properties of PCl3. PCl3 is a colorless oily liquid and hydrolyzes in moisture. So when treated with water, it forms H3PO3, phosphorus acid. So phosphoric acid is H3PO4, phosphorus acid is H3PO3 plus 3HCl. It reacts with organic compounds containing OH groups to form respective chlorides. Very, very important. So this phosphorus trichloride combines with organic compounds containing OH groups to form respective chlorides. That is what preparation of alkyl halides. What is this called? Preparation of alkyl halides. We can use to prepare alkyl halides by the use of PCl3. This reaction already have seen in organic chemistry. So the halogen replaces the OH group in these molecules. So when you take three molecules of ethyl alcohol along with PCl3, it forms ethyl chloride. Three molecules of ethyl chloride, it is called alkyl halide along with phosphorus acid. So phosphorus acid is byproduct. Similarly, acids. CH3COH on reaction with PCl3, it forms acid chlorides. It also prepares the acid chlorides, CH3COCl, acetyl chloride. So this is called acid chlorides. So PCl3 is used for the preparation of alkyl halides as well as acid chlorides. When it is treated with alcohols, it forms alkyl halides, and when it is treated with acids, that is acetic acid or ethanoic acid, it forms acid chlorides. I hope it's clear. So PCl3 is used and it is colorless oily liquid and hydrolyzed in moisture. It reacts with organic compounds containing OH groups and also COH group to form their respective chlorides. The halogen replaces the OH group in these molecules. See, OH is replaced with halogen. I hope it is clear. Next. Structure of PCl3. It has one lone pair of electrons. So in PCl3, phosphorus is sp3 hybridized like in case of ammonia and has a pyramidal shape due to the presence of lone pair of electrons. It undergoes pyramidal shape and bond angle also is reduced. So this is the structure of PCl5. Phosphorus pentachloride. Now let us see. It forms two types of halides, that is PX3 and PX5. Let us see now PX5. That is PCl5 example. So PCl5, phosphorus pentachloride, is prepared by the combination of phosphorus with excess of chlorine. And this is also white phosphorus only. White phosphorus with excess of chlorine, direct combination. So it forms. In that case, we have taken 6 molecules of chlorine. In this case, we have taken 10 molecules of chlorine. That's what excess of chlorine. Excess of chlorine means P4 on reaction with excess of chlorine, it forms PCl5. and it is also prepared by the action of thionyl chloride, SO2Cl2 on phosphorus. So white phosphorus on reaction with thionyl chloride, it forms PCl5 along with sulfur dioxide gas or water. So if you take excess of thionyl chloride also, you will get PCl5. So the preparation of PCl3 and PCl5 are almost same. Only the thing, we have to take the reactants in excess. That is, in the first case, chlorine in excess, and second case, thionyl chloride in excess. So 10 molecules of thionyl chloride. So it forms 4 PCl5 plus 10 SO2. I hope it is clear. So whichever important reactions I'll tell you, please note it down. That reactions are important for objective. Next properties. PCl5 is a yellowish white powder. It's very important. PCl5 is a yellowish white powder. It is solid in nature. So in moist air, it hydrolyzes to POCl3 and finally gets converted into phosphoric acid. So in moist air, it converts first into phosphorus oxychloride, which finally changes to phosphoric acid and HCl. So PCl5 is when heated is sublimes. Next reaction. When PCl5 is heated, it sublimes but gets decomposed on strong heating to give PCl3 and Cl2. So PCl5 on strong heating forms PCl3 and Cl2. So this is called here again disproportionate reaction, we can say, because chlorine is getting, so what is the oxygen state of chlorine here? Minus, it is minus 1, and here it is also minus 1, and here it is 0, minus 1 to 0 increase in oxidation state. But we cannot say it is disproportionation, just we have say it is forms like this. It is not a disproportionation reaction. So this reaction PCl5 on strong heating changes to PCl3 plus Cl2, that is phosphorus pentachloride on strong heating gives phosphorus trichloride along with chlorine gas. So when PCl5 is heated, it sublimes. Sublimes means it undergoes sublimation but gets decomposed on strong heating to give PCl3 and Cl2. I hope it is clear. Next, PCl5 reacts with organic compounds containing OH groups like PCl3. It also combines with organic compounds containing OH groups and replace OH group by chlorine atom. That is again preparation of alcohols and acid chlorides, sorry, alkyl halides and acid chlorides. So example, see here now. C2H5OH on reaction with PCl5, it forms C2H5Cl plus POCl3 plus HCl. This reaction is important. So when ethyl alcohol is treated with PCl5, it forms ethyl chloride, that is alkyl halide. Here OH group is replaced with Cl, ethyl chloride, alkyl halide. So alkyl chloride or alkyl halide, both are same. Plus POCl3 plus HCl. And this is not C2H5OH, it is CH3COOH. It is nothing but what? CH3COOH, acid group, carboxylic acid, that is ethanoic acid on reaction with PCl5, it forms CH3COCl. So COH group is replaced with Cl. CH3CO will be as it is, plus POCl3 plus HCl. So this is given wrong here, please note it down. Acetic acid on reaction with PCl5, it forms acid chloride along with POCl3 and HCl, phosphorus oxychloride. So acid chloride. This is called what? Acid chloride. This is called acid chloride. Next, PCl5 reacts with finely divided metals to form respective metal chlorides. So phosphorus pentachloride reacts with finely divided metals to form respective metallic chlorides. So silver chloride and stannic chloride. That is, with tin it forms stannic chloride. Whereas PCl3, if you take into consideration, it will not react. So these are the important reactions of PCl5. I hope it is clear. So please note down this reaction is wrong. So you have to note it down, change it into CH3COOH. Next. Structure of PCl5. In PCl5, phosphorus is sp3 hybridization. It undergoes what type of hybridization? sp3 hybridized. And it has trigonal bipyramidal structure because it has no lone pairs. It has 0 lone pairs in gases and liquid phases. So the bond angles in PCl5 are 90 degrees, 120 degrees, and 180 degrees respectively. Very, very important. The bond angles are very important. So this is axial bond angles and equatorial bond angles. Equatorial bond angles are in 90 degrees, axial bond angles 120 degrees and 180 degrees. So I hope it's clear. This is 90 degrees, this is 120, and this is 180. So the structure is very, very important. So PCl5, it has no lone pairs because It has 5 electrons. All the 5 electrons are occupied by 5 chlorine atoms. So that's why in PCl3 we have one lone pair, but in PCl5 no lone pairs on phosphorus in PCl5. Very, very important. So that's why it will take the regular shape, that is trigonal bipyramidal shape. Trigonal. The substance which is undergoing sp3 hybridase, sp3d hybridase will have the shape, regular shape, that is trigonal bipyramidal structure. Bipyramidal structure in gaseous and liquid phases. And the bond angles in PCl5 are 90 degrees, 120 and 120, 180 degrees. Generally, PCl5 exists as white powder, but here when you take it in gaseous phase or in liquid phase, you will get like this. So equatorial bonds, these are the two equatorial bonds, 90 degrees, and the axial bonds, 120 degrees and 180 degrees. This is 180 degrees. So axial bonds is 120 degrees, equatorial bonds is 90 degrees, and this is 180 degrees. I hope it is clear. Very, very important. Next, structure of PCl5 continued. The two axial bonds are longer than equatorial bonds because of higher bond pair repulsions. So in PCl5, this statement also they'll ask, which of the following is correct regarding PCl5? First statement, PCl5 undergoes sp3d hybridization, correct. PCl5 has trigonal bipyramidal structure, correct. The bond angles of PCl5 are respectively 90 degrees, 120 degrees, and 180 degrees, correct. And fourth statement, the two axial bonds are longer than the equatorial bonds. The two axial bonds are longer than the equatorial bonds because of higher bond pair repulsions. So, like this statement based question, they'll ask in the examination. So, all the statements are very important regarding structure of PCl5. Any three statements they'll ask in the examination. In solid phase, PCl5 exists as ionic solid. As I told you, PCl5 is white powder, so it is existing as solid. And this in solid state, what happens? It forms PCl5 changes to PCl4 plus and PCl6 minus. This is octahedral sp3d2 and this is tetrahedral sp3. So it is like ionic solid. So PCl5 is ionic solid. Very, very important point. These points they'll ask in the objective questions. So that's why these are all the points. So structure of PCl5 is most important. So please note down these 5 points. First point is what? PCl5 undergoing sp3d hybridization. It has, second point is what? It has trigonal bipyramidal structure. And third point, it has the bond angles are 120 degrees, 180 degrees, and 90 degrees respectively. And fourth point, the two axial bonds, that is, two axial bonds are longer than equatorial bonds because of higher bond pair repulsions. Why the axial bonds are higher, longer than equatorial bonds in PCl5 is due to bond pair repulsions. And fifth point is, in solid phase, PCl5 exists as an ionic solid. It is formed as PCl5 changes to PCl4 plus and PCl6 minus. So it is tetrahedral shape sp3 hybridization, and this is octahedral shape sp3d2 hybridization. So in solid phase, PCl5 exists as ionic solid because it forms ions. As it forms ions, in solid phase it exists as ionic solids. So very, very important, all these points. Next, oxo acids of phosphorus. Like in nitrogen, we have done oxo acids, like that we have done. Now we are going to do oxo acids of phosphorus. Very, very important. All the oxo acids of phosphorus are important. So their structures they'll ask and basicity also they'll ask. So first, hypophosphorus acid H3PO2, orthophosphorus acid H3PO3, pyrophosphorus acid H4P2O5, hypophosphoric acid H4P2O6, orthophosphoric acid H3PO4, and pyrophosphoric acid H4P2O7, and metaphosphoric acid HPO3 taken n times. So all these are very, very important. So this is called phosphorus forms 7 types of oxo acids: hypophosphorus acid, orthophosphorus acid, pyrophosphorus acid, hypophosphorus acid, phosphoric acid. Orthophosphoric acid is very important, and pyrophosphoric acid and metaphosphoric acid. All these acids, these are the different variety of oxide. Why it is forming many oxides? Because it has empty d orbital. Empty d orbital. Why? Because d orbital starts from 3, principal quantum number 3. When you take phosphorus, atomic number is 15, so its configuration is 1s2, 2s2, 2p6, 3s2, 3p3. So it enters into principal quantum number 3. Principal quantum number 3 means it has empty d orbital. So in 3D only we have 3D orbital, emptied 3D orbital. So that's why it can form many oxo acids. So I hope it is clear. Now let us see the oxo acid structures. The oxo acids of phosphorus containing P double bond O bonds and POH bonds. It contains mainly two types of bonds. One is what? P double bond O, and there is POH bonds. How many PO bonds and how many POH bonds they'll ask in exam. In addition, they may contain PP bonds and also PH bonds. The oxo acids containing pH bonds acts as reducing agents. Very important point. So the oxo acids containing pH bonds acts as reducing agents. The hydrogen atoms of pH bond are not replaceable and hence do not contribute to the basicity of the acid. Next, the oxo acid with phosphorus in plastic state tend to disproportionate in solution. They undergo what type of reactions? Disproportionation. Disproportionation means simultaneous oxidation and reduction only one element in the reaction. So that is called disproportionation reaction. So the oxo acid with phosphorus in plus 3 oxygen state tend to disproportionate in solution. They undergo disproportionation reaction in solution. So the underlying points are most important. Please note it down in your classwork. So basically, the oxo acids of phosphorus contain only P double bond O bonds and POH bonds. In addition, they may contain PP bonds and PH bonds. The oxo acids containing pH bonds act as reducing agents, and pH bonds are not replaceable and hence do not contribute to basicity of the acid. Next, only OH bond is replaceable, hence they contribute basicity of the acid. Next, structure of oxides. Hypophosphorus acid. It contains two pH bonds, one POH bonds, and one PO bonds. So hypophosphorus acid contains what? Two pH bonds. It is a reducing agent. One POH bond. Hence basicity is equal to 1. Since it has one POH bond, its basicity is equal to only 1. And it contains P double bond O bonds, one P double bond O bonds. So this is the structure of hypophosphorus acid. Basicity is equal to 1, even though it contains three hydrogen atoms, but its basicity is 1 because only it contains one POH bond. They'll ask basicity of hypophosphorus acid. Next, orthophosphorus acid, H3PO3. It has two POH bonds. So it has two POH bonds. So basicity is 2. And it has one PO bond, one P double bond O bond, and one PH bond. So which is more reducing? This is more reducing than this because it contains only one pH bond, whereas it contains two pH bonds. And basicity is 2. Why? Because it contains two POH bonds. So one pH bond. Next, orthophosphoric acid. It contains three POH bonds. That's why it is strongly acidic. So three POH bonds. So basicity is equal to 3. And for this basicity is equal to 2. Basicity is equal to 2. Basicity means number of replaceable OH minus ions. It is nothing but basicity of the acid. So basicity of the number of replaceable H plus ions. So it contains, as it contains two POH bonds, its basicity is 2. It contains three POH bonds, its basicity is 3. And it is containing one P double bond O bond and three POH bonds. So all these structures are very important. So please note it down, practice these structures. Definitely you will get questions based on structures. Next, pyrophosphorus acid. It contains how many POH bonds? One POH, two POH bonds, and one POP bond. Very important. It contains one POP bond. POP bond, one POP bond, and two POH bonds. So basicity is equal to 2. Basicity is equal to 2. So hypophosphoric acid, it contains 4 POH bonds and two P double bond O bonds. So 1, 2, 3, 4. Next, pyrophosphoric acid, it contains two POH bonds, one POP bond, two pH bonds. So this is very important. Pyrophosphoric acid, it contains all the types of bonds. That is two P double bond O bonds. Next, two POH bonds. Next, one POP bond. Next, two pH bonds. So all this they'll ask in the examination. So this is called pyrophosphoric acid. It contains two POH bonds, one POP bond, two P double bond O bonds, and one pH bonds. This is the only which contains. So this and this pyrophosphorus acid and pyrophosphoric acid will contain all types of bonds of phosphorus, oxygen, and hydrogen, etc. Next, structure of oxo acids of phosphorus. Last one, metaphosphoric cyclic acid cyclic. HPO3 taken 3 times. HPO3 taken, it has POH bonds 3. So base is equal to 3. Base is equal to 3 because it contains 3 POH bonds. Base is equal to 3. So, and P double bond O bonds, like this structure it will go. So this is called HPO3 taken thrice. How many sigma bonds and pi bonds are present in HPO3 taken thrice? Also they can ask. So number of sigma bonds: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 11 sigma bonds. It has how many sigma bonds? 11 sigma bonds. And how many pi bonds? 3 double bonds are there. So 3 pi bonds. So once again we can count. And OH also we have OH directly. So 1, 2, 3, 4, 5, 6, 7, 8 like that. So even if you take for OH also, you'll get 11 plus 3 sigma bonds because OH also related like this. So that's why 11 plus 3 is, that is 14 sigma bonds and 3 pi bonds. 14 sigma bonds and 3 pi bonds. That's very, very important. So this is clear. So these are the oxo acids of phosphorus. Now, why red phosphorus is dense and chemically less reactive than white phosphorus? Because red phosphorus is regarded as polymer because it contains long chain of tetrahedral crystals joined together, long chain of tetrahedral P4 tetrahedral linked together. That's why it is dense and chemically less reactive. Next question. Which of the following oxy acids is formed from P2O3? HPO3, HP4O2. Which of the oxy acid is formed from P2O3? So we have D, that is H3PO3, you'll get P2O3. When you heat H3PO3, you'll get P2O3. Next question. Explain the action of heat on ammonium nitrate, and ammonium chloride. So it is nothing but you can see that clearly. So ammonium nitrate, ammonium chloride, and ammonium chloride. Ammonium chloride on heating gives ammonia. It forms ammonia. Ammonium nitrate, it forms nitrogen dioxide gas. Ammonium nitrate, it forms nitrogen monoxide gas. These reactions you can see in the classwork. I hope it is clear. Next. So with this, we have completed this chapter. Now I will be writing questions based on this chapter, based on phosphorus, because we have already done for nitrogen. Now we'll do questions based on phosphorus, previous competitive questions for in case with respect to phosphorus, previous competitive questions. Previous competitive questions for phosphorus. Then we'll discuss summary of the chapter. So let us discuss some few questions based on phosphorus. After that, we'll go for summary of the chapter. This chapter is completed now. So ammonium chloride and this now first question. Question number 1. Aqueous NaOH. That is aqueous sodium hydroxide. On reacts with white phosphorus. Reacts with white phosphorus to form phosphine and to form phosphine and. So what is the other product they're asking in the examination? Is try to neat question. Option A, NaH2PO2, that is sodium hydrogen phosphide, hypophosphite. Second one, P2O5, that is option B, P2O5. Option C, please note down in your class of these questions, Na3PO3. And option D, P2O3. So from phosphine, aqueous NaOH on reaction with white phosphorus to form phosphine as well as other byproducts. So answer is NaH2PO2. You can refer the equation, that is preparation of phosphine from white phosphorus, which is taken and which you have given in the slides. Second question. Second question now, based on phosphorus. In the oxyacids of phosphorus, in the oxyacids of phosphorus, the hybridization of phosphorus is the hybridization of phosphorus is very, very important question. All the phosphorus will undergo only one type of hybridization. Hybridization of phosphorus is, first option we have sp3, second option we have sp2, third option we have sp, and fourth option we have dsp2. So answer is, since in all the oxidations of phosphorus, phosphorus is linked to only single covalent bond, so it undergoes sp3 because on the four sides it is connected tetrahedral units, so it is called sp2 hybridization. sp2 hybridization. I hope it is clear. So sp3 hybridization. So this is question number 2. Next question. Question number 3. Next question I'm writing. The anhydride of phosphoric acid is anhydride of phosphoric acid is means from phosphoric acid, if you remove water you get anhydride. If you remove water from phosphoric acid you'll get its anhydride, so that's H3PO4. So option A, P4O6 is orthophosphoric acid. Here I have forgot to write orthophosphoric acid. Option B, P4O10. Option C, we have P2O4, and option D, we have P2O2. So answer is P4O10, tetraphosphorus decoxide. Tetraphosphorus decoxide, that is P2O5 again. So this is the anhydride of orthophosphoric acid. So these are the 3 questions. More number of questions we are doing to now. So please note it down these questions in your classwork because these slides will not be there in the video. So only in the video you can see because I have not shared these slides. So please note down all these questions along with the answers. Next question. Question number 4. Question number 4. The salt of the following uses as used as a water softener. Water softener. First option H4P2O6. Second option H4P2O7. Third option HPO3. Fourth option HPO3, and fourth option is HPO2. So answer is HPO3. Excuse me. Next question. So all these uses are also important. They're asking uses also. Next, question number 5. Very, very important. A tribasic acid with peroxy bond is a tribasic acid. This question is very important. This is based on oxoacids of phosphorus. Tribasic acid with peroxy bond is, it should be tribasic as well as peroxy bond. Very, very important. Option 1, H3PO3, sorry, H3PO2. First of all, H3PO2 is not tribasic, it is monobasic because it contains only one POH bond. Option 2, H3PO3, it is dibasic. Option C, H3PO4, it is tribasic, but it has no peroxy bond. And option D, finally, H3PO5. So if you take H3PO2, it is monobasic because it contains only one POH bond. One POH bond. And they're asking about peroxy bond means what type of bond? POP bonds. And H3PO3, it contains only, its basicity is 2 because it is dibasic acid. And H3PO4, it is tribasic, but it has no POP bonds. It has no POP bonds. Whereas H3PO5, it has POP bonds. So answer is D, it is tribasic also. So they're asking tribasic acid with peroxy bond. See, H3PO3, so peroxy bond means POP bonds they're asking. So answer is fourth option. So this type of question, as I told you, they can ask either basicity or they can ask structure based questions. So this is nothing but structure based questions. Next question. The oxidation state of phosphorus. The oxidation state of phosphorus is least in first option pyrophosphoric acid. Right here. First option. First option they have given hypophosphoric acid. You should know the formulas of this. Then only you can understand easily. Second option. Option B. Hypophosphorus acid. Hypophosphorus acid. Third option. Metaphosphoric acid. And fourth option is D. Pyrophosphoric acid. So out of all this, which is having the oxidation state of phosphorus is least in which. So if you know the formula, you can easily get the answer. So answer is hypophosphorus acid. The formula of hypophosphorus acid is H3PO H4P2O7. So H4P2O7. So in this case, the oxidation state of phosphorus is least. So hypophosphorus acid, refer to the formula, and you can refer the formula of all these four because I have given all the formulas of this in the oxy acids of phosphorus. So you can refer and calculate. The answer is hypophosphorus acid. I hope it is clear. Next question. Question number 7. Based on phosphorus, we have to answer like these questions. So all the questions on phosphorus is very, very important. Next we have next question. Please note it down. Which of the following next question I'm writing here, please note it down in your classwork. The statements regarding oxy acids of phosphorus. The statement regarding oxy acids of phosphorus are statement 1, first statement, they are given HPO3 molecule has POP linkage, that is peroxy linkage. Second statement, H4P2O7 molecule has, HPO3 molecule is monobasic acid, just is monobasic acid. Monobasic means it has only one POH bond. Monobasic acid. Second statement, H4P2O6 molecule. H4P2O6 molecule has PP bond. Next, third statement. H4P2O7 molecule has, third statement, H4P2O7 molecule has POP linkage. So they are given three statements and they are asking options here, which is correct. The correct combination is, the question is the correct combination is, option A, all are correct. Option B, only 2 is correct. Only second statement is correct. Option C, 2 and 3 are correct. Option D, 1 and 3 are correct. So let us discuss the answer now. HPO3 molecule. HPO3, the structure is what? 1 phosphorus, 1 POH bond will be there definitely, 1 P double bond O and 1 PH bond. So HPO3. So it is nothing but what? HPO3. So 2 oxygens, no? So it is 1 double bond O. So this is the structure of HPO3. HPO3. This is the structure of HPO3. It has basic is 1 because it has only one. It has only one OH bond. So first option is correct. Let us see second option. H4P2O6. Let us take H4P2. So it is P double bond P and here OH and here OH and here double O and here H. Sorry, H and here P double bond O and here P double bond O. So like this, if you refer to this, definitely this is also, it contains one PP bond. So this is also correct. And H4P2O7 has one POP linkage. So please refer the structures. So all the statements are correct. All are correct. So answer is what? All are correct. All are correct. Like these questions you'll get in the examination. So please refer all these things. Next question. Question number 8. Next question. PCl5 and hydrolysis gives. PCl5 on hydrolysis gives option A H3PO3, option B H3PO4, option C H3PO2, and option D H3PO5. So PCl5, if you take PCl5 and hydrolysis, it will give orthophosphoric acid. If you take PCl3 and hydrolysis, it will give metaphosphoric acid, that is H3PO3. So PCl5 and hydrolysis gives orthophosphoric acid. So this is right answer. So H3PO4. Next question. So everything they are asking in the exam. So that's why we should not even miss one sentence also. Aqueous solution of PCl3. Aqueous solution of PCl3, phosphorus trichloride, conducts electricity due to the presence of option A HOCl, option B HCl, option C H3PO4, and option D H2O. So answer is due to the presence of HCl only, because when you take PCl3 and water, it forms HCl gas. So due to the presence of HCl only, it conducts electricity. Next question. The shape and hybridization of PCl3 molecule is the shape and hybridization of PCl3 molecule is option 1. It is tetrahedral and sp3. Tetrahedral and sp3. Option 2. That is second B option. Pyramidal and sp3 and sp3. Option C. Angular and sp3. Option D. Planar, triangular, planar, and sp3. In all the cases, they are given sp3. sp3 is right only, but the answer is pyramidal because it has one lone pair of electrons. Since PCl3 has one lone pair of electrons, its shape is pyramidal and hybridization is sp3 hybridization. I hope it is clear. So these are the questions, maximum possible questions I have given. So some other questions also easily by seeing the lectures you can understand, and you can do many questions as you can. Now we'll see the summary of the chapter, that is summary of the topic. So 15th group elements is finished. Now we are taking summary of the chapter. So in this first, what we have done, 15th group elements, first we have done general physical properties. General physical properties. In physical properties, we have done about electronegativity, atomic size, ionic radius, atomic radius, and so on. Next, we have general chemical properties. In general chemical properties, we have halides, oxides, as well as hydrides. General chemical properties. That is about general chemical properties. That is what you have done: hydrides, halides, and oxides. So next third point topic we have done nitrogen and its compounds. Nitrogen and its compounds, preparation, properties, and uses. and its compounds. That is preparation, properties, and uses. Preparation, properties, and uses. And fourth one, what we have done, phosphorus and its compounds. Phosphorus and its compounds. So again, we have done preparation, properties, and uses. So in all these cases, general physical and chemical properties are most important, along with nitrogen and phosphorus. In nitrogen and phosphorus, what you have to study, oxo acids of nitrogen and phosphorus, along with structures, are most important. So just only 4 topics we have. In all these 4 topics, we have covered everything. That's why this chapter is very, very small. So this is the summary of the chapter. So prepare well for all the questions, and easily if you read all the this is just like reading only, because only memorizing, less logic. So that's why if you read the chapter thoroughly for 2 3 times, definitely you can answer many questions. I hope it is clear. So this we have completed 15 group elements. Now next we will do 16 group elements. So we have completed 15 group elements so far. So please go through what we have instructed carefully, what is whole me signal, etc. So that questions, more number of questions you can do in the objective material. Thank you all.